All right, various variations. There are a couple different kind of variations. There's 3 or 4 or 26 or something like that. We're mostly going to talk about 2 because that's what's in our TEKS. That's what we have to talk about. Okay, if we have time, we'll talk about some other kind. But right now, we're going to focus on these 2. All right. Anybody have this table filled in yet? What you got? Tell me just the table. All I want is the table values. 12, 30, and 38. Does anybody agree with him? Yes? Okay, did you get an equation? Y equals 4x. Anybody agree with that? Okay. Anybody have number 2 table? What you got? 15, 7.5, and 5. Because this time when we're still talking about area, this time we know what? We know the area and we know a length. Let's see, x is length. So yeah, we know a length. Okay. So what equation did you find? 60 equals x times y. Sorry for the 6. What you got? So you solved it for y and got 60 over x. Would that be true if I divided both sides by x on that first one? Yes? So which one's right? Both? Okay, good. I'm finally getting you to understand that sometimes problems in math can have more than one answer, and we're okay with that, right? Good. Anybody have number 3? Somebody else since they answered before. Who has 3? Seriously. What you got? Read it. Read it. 7.5, good. 15, good. 17 and a half. Whoops. 17 and a half. Ignore that one. How did you find these answers? Do you use similar triangles, hopefully? Maybe the height of the tree over the length of the shadow would have to equal the height of the man over the length of his shadow? Maybe. That's one of 4 possibilities. And then if I solve that for y, that would give me even more possibilities. Okay? If I solved it for y, that would give me 5/3 times x, because I'd multiply both sides by x, right? You okay with that? Okay. So hopefully on 4 you also use similar triangles? Maybe? I said hopefully on 4 you also use similar triangles? Maybe? Like the height of the small triangle over the length of the small triangle, and that should equal the height of the person. Do we know that? Oh, 60 over the length of that they are away from the mirror. Right? And if I just solve for y again, if I multiplied both sides by 30 to get rid of that denominator, I'd get y equals 1800 over x. Yes? Are you okay today? So in the table we got 90, 45, and what'd you say? 30? Good? Okay so far? So what about this one? Can we use similar triangles here? No, that's ridiculous, isn't it? For X people to travel, the cost Y in dollars for renting a bus is $7.50 per person. So if 10 people are going, it should be $75. What about if 25 people are going? $187.50, good. And if 30 people are going? $225. How did you get that? What equation did you use? 7.5 times x equals y. How do I feel about that? Okay, we can forget the 0. That's no problem. Okay. How do I feel about the equation written like that? It's fine, isn't it? What do, like, strict math people want it to say? Y equals 7.5x, right? Does that get the point across? Then we're fine. Some people are freaking out, though, because it's not y equals. You'll be all right. What about 6? Is it the same problem? It has the same bus. Oh, it's not the same problem? Okay. This time the bus costs $180, period, no matter how many people ride, right? So what if only 8 people ride? How much is it going to cost? $22.50. How did we get that? How did you get that? So 180 divided by 8? Okay. 15 and 6. Because if 30 people ride and it costs 180, they would each pay $6 each, right? Okay. So what equation did you use? Is there another possible equation to figure this out? What is it? Yeah, exactly. Okay. Okay so far? We weren't so okay on the similar triangles ones though. Are you okay with those now? Ish? Better than before we talked about them? Yes? Okay, good. So let's answer these questions. Look at just problems 1, 3, and 5. What do they have in common? Look at just their tables. 1, 3, and 5, which I can't put on the same page because they're on front and back. You'll be fine. As x, what's happening with x every time? What happens to the values of x? It's increasing. As x increases, what is happening to the y's? Look at them. Look at the tables in 1, 3, and 5. They are, aren't they? As x increases, then y increases. Do you want to do all about 1, 3, and 5 and then do all about 2, 4, and 6, or do you want to do them at the same time? Same time? Okay. So let's look at 2, 4, and 6. What do their tables have in common? What's happening with their x's? Are they? Increases. The y's what? Decrease. For every one of them? X is increasing, y is decreasing. X is increasing, y is decreasing. X is increasing, y... Oh my goodness. So the relationship in 1, 3, and 5, look at how we have written the equations. Y equals 4x. Y equals 5/3 x. Y equals 7.5x. It's called a common ratio. Okay? Or when we did like linear functions, what was that called? Y equals something x? M? What was it? It was a slope, right? And the other thing we called it was a rate of change, right? I want to be able to call it all 3 of those, so that's why I have you written all 3. Okay? But what about this one? Look how we have this written. xy equals 180. I could write this xy equals 1800, couldn't I? xy equals 60. What do they have in common? It is a common product. Excellent. Every once in a while you guys surprise me with your knowledge, and then every once in a while you surprise me like 5 days in a row with your knowledge. So that's a good thing. Okay? So what kind of equations what does this equation look like? 1, 3, and 5. What does that equation look like? Y equals something x. For this, we're going to call it a k. And the reason we call it a k is because it is a constant. I know constant starts with C. Isn't that funny? I really don't know. We just call it, it is a constant that's there, a constant multiplier, and for whatever reason they represent it with a K. Alright? Right, so this one, the 2, 4, and 6, x times y equals K. Say it. K over x. Either one of those. And depending on the situation, we might need both. Okay? We want to be able to use one or the other. This one is called excellent, direct variation. This one is called what? Here's a sample problem that you will see. If y varies, how is it varying? Directly. As x, so it's telling us y varies directly with x, and y equals 12 when x is 8, then what is y when x is 24? So it's telling us enough to first find k. That's what we have to find first is k. Okay? So if we know that y is 12 and x is 8, well, come back to this, right? I know that y is 12 and x is 8. So how do I solve for k? Divide both sides by 8, right? 8 divided by 8 is 1. So what is 12 divided by 8? K is 1.5. Does that answer my question? Did I just find y? No. I found k, so I have to start over again. Y equals 1.5x. Well, this time I know what is y when x is 24. 1.5 times 24. What is 1.5 times 24? Are you sure? Okay. It's 36. So that answers my question, doesn't it? Whoa. Pretend you didn't see that. Okay? Okay so far? I'm waiting. So we kind of have to do two separate parts, right? First I have to find k with the information I'm given, and then I can use k to answer the question. Does that make sense? Can I show you in just a second? Will that be okay? Okay. Look at the second one, 2, 4, and 6 for the examples. If y varies inversely as x and y equals 12 when x equals 8, then what is y when x equals 24? So wait, how are these two problems different? Except for how they vary, right? This one very clearly varies directly. This one very clearly says inversely. All right? So once again, we start by finding k. So to find k, don't you think this one would be easier? Because it's already k equals something. Okay? So I know that yx equals k. Well, I know y is 12 and x is 8. So how do I find k? 12 times 8. What is 12 times 8? 96. So k equals 96. So this says, what is y when x is 24? Which one is it going to be easier to use to start with? Aren't they the same? Yes, but because of what they're solved for, one of them might be easier to use than another one, right? So this time it might be y equals 96 over x. Well, I know that x is 24, don't I? So what is 96 divided by 24? 4. Does that help a little bit? Yes? Okay. Look at the other page I gave you. There are 10 questions on this page. Okay? 10 questions on the page. 4 at the top say, please identify whether each table shows direct variation, inverse variation, or neither. How are you going to tell by looking at a table if it's direct variation? If y increases, if x increases, look at what y does. If it increases, it is direct, and if it decreases, it is. Okay, how are you going to tell if something's neither? If it doesn't do one or the other, right? If it doesn't do one of these two things, it's neither. Fair enough? And then these 6 questions right here are exactly like these 2 samples I gave you at the bottom of the page. Any questions? Good?